Today we'll discuss CMI's 2022 paper, which was conducted on 22nd May. And the first question is, suppose A0, A1, A2, A3 be an arithmetic progression with A0 and A1 positive integers, and let G0, G1, G2 be geometric progression such that G0 equals A0 and G1 equals A1, then which of the following statements is or are correct? Now, if we look at this arithmetic progression, then the terms are A0, A1, A2, A5, and then we have A8, A9, and A10. And we know that in an AP, arithmetic mean of rth term from the beginning and rth term from the end, it is equal to its middle term if it has odd number of terms. So in this case, A0 plus A10 by 2 will be equal to A5. Now AM is greater than equal to GM, so it will be greater than equal to under root of A0 A10, and we square it, we'll get this as A5 square will be greater than or equal to A0 into A10. That means the statement 1 is correct. Now the statement 2 is the sum A0 plus A1 up to A10, it must be a multiple of integer A5. As stated previously, A0 plus A10 by 2 will be equal to A1 plus A9 by 2. I'll go all the way up to A4 plus A6 by 2 and will be equal to A5. So this sum, say S, it can be expressed as 2 times A5, 2 times A5, 5 times, and plus A5, which is simply 11 times A5, which is a multiple of integer A5. That means the statement 2 is also correct. Now this third one is sum of infinite terms of this AP, that is this summation I varies from 0 to infinite AI, it is plus infinite. It simply means that it is an increasing AP with common difference greater than or equal to 0. So basically A1, it will be greater than or equal to A0. Now for this GP, its common ratio, it will be A1 upon A0, and A1 upon A0 is greater than or equal to 1. And since R for this GP is 1 and greater than 1, and it contains positive terms, sum of GP will also diverge. So sum of the GP will also be plus infinite. That means statement 3 is also correct. Now if we look at this statement 4, it says sum of infinite GP, it is finite. Now we know that the sum is finite when R or mod R, it is less than 1. Now it means A1 upon A0 will be greater than minus 1 but less than 1, and from here we'll get A1 is less than A0. Now if A1 is less than A0, then basically common difference is less than 0, and if common difference is less than 0, then sum of infinite terms of an AP will be minus infinite. That means this statement 4 is also correct. So all the 4 statements 1, 2, 3, 4, they are correct. Now question number 2 is, we are given 2 events A and B, and probability of A and B, they strictly lie between 0 and 1, then which of the following statements is or are true? Now this first one is A and B are mutually exclusive if and only if not A and not B are exhaustive. So we are given that A and B are mutually exclusive. If A and B are mutually exclusive, then P A intersection B will be 0, and we have to prove this is possible if and only if not A and not B are exhaustive. That means probability of A0 union B0, it is equal to 1. Now if we look at this probability, then it will be this probability of A intersection B0 will be 1. So from here we'll get probability of A intersection B will be simply 0. So we can prove it both ways. We can start from P A intersection B, taking it at 0, and then we can write probability of A0 union B0 will be probability of A intersection B0, which is 1 minus probability of A intersection B, and it is 1. That means if A and B are mutually exclusive, then A0 and B0 are exhaustive. And if we start from this, P A naught union B equals 1, then we get P A intersection B as 0. So if A naught and B naught, they're exhaustive, it implies A and B are mutually exclusive. That means this statement 5 is correct. Now, sixth one is A and B are independent if and only if not A and not B are independent. Now, this is standard result, but anyways, we'll prove it. So for this sixth, let us assume A naught and B naught, they are independent. That means P A naught intersection B naught will be probability of A naught into probability of B naught. Now, this is probability of A union B naught, and this is equal to P A naught into P B naught. Now we can write this as 1 minus probability of A union B, and it will be equal to 1 minus probability of A into 1 minus probability of B. Now P A union B is PA plus PB minus PA intersection B, so it will be 1 minus PA minus PB plus P A intersection B, and it will be equal to 1 minus PA minus PB and plus PA into PB. Now this 1 PA PB will cancel. So from here, the only condition that we get is probability of A intersection B is probability of A into probability of B. So if A naught and B naught, they are independent, then it implies A intersection B is also independent. And we can prove vice versa also. So if we assume P A intersection B as P and PB, that is A and B are independent, then we can write probability of A naught intersection B naught as probability of A union B naught, which is 1 minus probability of A union B. That will be 1 minus probability of A minus probability of B and plus probability of A intersection B. Now probability of A intersection B is PA into PB. So we can write this as 1 minus PA minus PB and plus PA into PB. Now if we take these together, then we can factorize this as 1 minus PA into 1 minus PB. So it will be this PA naught into PB naught. That means A naught and B naught are independent. So that means this statement 6 is also correct. Now this sixth one is A and B cannot be simultaneously independent and exhaustive. Now suppose A and B are exhaustive. That means probability of A union B is 1. And if probability of A union B is 1, we can write P A union B as probability of A plus probability of B minus probability of A intersection B. Now if A and B are independent, we can write this as 1 equals PA plus PB minus PA into PB, and we can factorize this as 1 minus PA into 1 minus PB. It is equal to 0. From here we get this condition that either PA is 1 or probability of B is 1, but in the question it says both probability of A and probability of B, they strictly lie between 0 and 1. That means the statement 7 is also correct. Now statement 8 is A cannot be simultaneously mutually exclusive and exhaustive. Now this is not true. Basically when we talk about complementary events A and A naught, we know that probability of A intersection A naught, it is 0, and probability of A union A naught, it is 1. So for event and its complement, this condition is always true. Two events A and B, they can be mutually exclusive as well as exhaustive. Say for example, tossing a coin. If A is getting a head and B is getting a tail, then both these events are mutually exclusive and exhaustive. That means this option 8 is incorrect. Now this third question is we are given two matrices A and B where K is any constant and X, Y and Z, they are variables. Now we have to find which of the following statements they are correct. Now if we look at determinant of A, then determinant of A will be 1, 2, 3, 10, 20, 30 and it is 11, 22, K. Now if we write R2 as R2 minus 10 R1, then it will be 0, 0 and 0. That means value of this determinant A is 0. That means this matrix A, it is not invertible. So this statement 9, it is correct. Now 10th is, there is a unique case such that determinant of A is 0. Now this determinant of A is 0 regardless of values of K. So this K, it can take infinitely many values. That means this statement 10, it is incorrect. Now 11th one is, we are given this matrix equation AB equals 0, 0, 0. Now basically it is a system of homogeneous equations. And in this case, determinant of A is equal to 0. So if determinant of A is equal to 0, that means it will have non-trivial solution or infinite solutions. Now basically, if we look at these three equations will be x plus y plus z equals 0, 10x plus 20y plus 30z equals 0, and then 11x plus 22y plus kz equals 0. Now if k is 33, in that case, all these three equations, they will represent the same equation, x plus y plus z equals to 0, which is equation of plane. So in this case, all the solutions of this system of equation will lie on this plane. And if k is unequal to 33, then we have two non-parallel, non-identical planes, 11x plus 22y plus kz equals to 0, and these two planes, they'll intersect in a line. That means this statement 11 is correct. Now this 12th one is, we are given this matrix equation AB equals PQR, and it says if it has a solution, then Q must be equal to 10P. Now if we write equations for first two rows, then we'll get x plus 2y plus 3z, it is equal to P, and then from the second one we'll get 10x plus 20y plus 30z, and it will be equal to 2. Now we multiply this first one with 10, we'll get 10x plus 20y plus 30z, it is equal to 10p. Now the system of equation will be consistent if 10p is equal to q. So in order to get a solution for this, q must be equal to 10p. That means the statement 12, it must be correct. So the statements 9, 11 and 12, they are correct, and statement 10 is incorrect. Now here we are given a function f whose domain is in this closed interval 0 to 1, and we are given three conditions. First is f is differentiable at each x belongs to 0 to 1. Second is f is continuous at each x belongs to 0 to 1. And third is this set fx has a maximum element and a minimum element. Now which of the following statements is correct? Now this 13th statement is, if one is true, then second is true. If function is differentiable in closed interval 0 to 1, then it is continuous. It's a well-known concept. The differentiability implies continuity. That means this statement 13, it is correct. Now 14th is, if function is continuous in this closed interval AB, then it will have a maximum element and a minimum element. Now this result is nothing but this is extreme value theorem. So if function is continuous in closed interval AB, it will have a maxima as well as a minima. That means the statement 14 is also correct. Now 15th is, if third is false, then first is false. Now when this function fx, it doesn't have a maximum element or a minimum element or both, then basically this function fx is discontinuous. And if it is discontinuous, it is not differentiable. So if this third statement is false, that means this function is not differentiable. So if third is false, then first is also false. That means this statement 15 is also correct. Now 16 is, no two of the three given conditions are equivalent to each other. Now basically if we look at first and second, then first implies second, but second, it doesn't imply one. In the same way, second implies third, but third doesn't imply second, and first implies third, but third doesn't imply first. So all the three statements, they are not equivalent to each other. That means the statement 16 is also correct. So the correct statements are 13, 14, 15 and 16. Now question number 17 is let a equals 1 upon ln 3, then 3 to the power a equals e. Now what we can do is we can write this a as log e base 3, and if we take anti-log, then we can write 3 to the power a equals e. That means statement 17 is correct. Now if we look at the statement 18, we can write this sine 0.02 as sine 2 into 0.01. Now sine 2 theta is 2 sine 0.01 into cos 0.01. Now cos 0.01 is less than 1, so it will be less than 2 sine 0.01. That means statement 18 is also correct. Now 19th is arc 10.01 is greater than 0.01. Now we know that tan x is always greater than y equals x. So this is y equals x, and that's your tan x, and tan inverse x is basically reflection of tan x about y equals x line. So when x is nearly 0 or 0 positive, then tan inverse x, it is less than x and it is less than tan x. So basically this tan inverse of 0.01, it should be less than 0.01, which is less than tan 0.01, which means the statement 19 is incorrect. Now statement 20 is this integral. So we can write this integral as sum I, and this is from 0 to 1 tan inverse x dx. Now we'll take 1 and tan inverse x. Now tan inverse x is first function and 1 is your second function. We'll use by parts. So this is I. Now it is tan inverse x and x minus this integral from 0 to 1 will be derivative of tan inverse x 1 upon 1 plus x square into x dx. So there will be x dx upon 1 plus x square. Now we'll multiply and divide everything with 2. Here we'll put this limit from 0 to 1. Now this I is tan inverse 1. Tan inverse 1 is pi by 4, and then 1 minus 0, and then minus 1 by 2 log 1 plus x square from 0 to 1. So this integral will be pi by 4 minus 1 by 2 log 2. Now we multiply everything with 4. We can write 4 times this integral, and this is pi minus 2 log 2, which is pi minus log 4. That means the statement 20 is also correct. Now for the 6th question, we are given this function fx as 1 upon mod log x into 1 by x plus cos x. Now we can take this limit x tends to infinite fx, and will be this limit x tends to infinite. Now when x is positive, mod log x is simply log x, so it will be 1 upon log x into x plus 1 upon log x into cos x. Now when x tends to infinite, log x tends to infinite, so it will be 1 upon infinite, which is 0, and here also it will be 1 upon infinite, which is 0, into cos infinite, which is oscillating value between minus 1 and 1. So value of this limit is 0. That means the statement 22, limit of fx does not exist when x tends to infinite, it is incorrect. Now what about this 21? As x approaches infinite, we have this term 1 upon log x into cos x. Now this cos x will oscillate between minus 1 and plus 1. So value of this function fx is going to oscillate when x tends to infinite. That means this statement 21 is correct. 23rd is as x tends to 1, fx tends to infinite. Now if we take this limit x tends to 1, 1 upon mod log x 1 upon x plus cos x. Now it will be 1 upon mod log 1, and this is 1 plus cos 1. Now 1 plus cos 1 is positive. Now log 1 is 0, and basically this is 0 positive, and 1 upon 0 positive is plus infinite. That means this statement 23 is correct. And if we take this limit x tends to 0 positive, limit x tends to 0 positive fx, we'll have this as this limit x tends to 0 positive. Now when x is 0 positive, log x is negative. So it will be minus 1 upon log x, 1 upon x plus cos x. Now log 0 is minus infinite. So this value will approach infinity. So this statement 24 is also incorrect. So the correct statements are 21 and 23. Now in question number 7, we are given that f0x is x, and for x greater than 0, we have defined this function inductively by fn plus 1x equals x to the power fnx. So we have f1x as x to the power x, f2x as x to the power x to the power x, and f1 and f-10, it is 1. Now this first one is as x tends to 0 positive, f1x tends to 1. So we have defined this limit x tends to 0 positive, f1x, and f1x is x to the power x. So it will be this limit x tends to 0 positive, x to the power x, which is 0 to the power 0 form. Now we can write this as e to the power, this limit x tends to 0 positive, x log x, or this is e to the power limit x tends to 0 positive, log x upon 1 by x, which is infinity upon infinity form. Now this is e to the power limit x tends to 0 positive. Using L'Hopital's rule, we'll have 1 by x and minus 1 upon x square, which is e to the power 0, and that is 1. That means statement 25 is correct. Now we look at this limit for 26, which is limit x tends to 0 positive, x to the power x. Now we can write this as this limit x tends to 0 positive, x to the power x. Now we know that this limit x tends to 0, x to the power x, it is 1. So it will be this value 0 to the power 1, and 0 to the power 1 is 0. That means statement 26 is incorrect. Now this 27th is this integral from 0 to 1 f3x dx, which is this integral from 0 to 1. Now f3x is x to the power x to the power x dx. Now if you look at this function f3x, it is x to the power x to the power x to the power x. X lies between 0 and 1. Now here x to the power x to the power x to the power x will always be less than or equal to 1. Now if we take this integral from 0 to 1, x to the power x to the power x to the power x to the power x dx, it will be less than this integral from 0 to 1 dx, as this function is not a constant function. Now this is 1. So value of this integral is always less than 1 and not equal to 1. That means this statement 27 is also incorrect. Now this 28 is derivative of f123 at x equals 1. Now here we are given that fn plus 1 x equals x to the power fnx. So basically yn plus 1, it is equal to x to the power yn, and if we take log and differentiate, we can write this as log y n plus 1, it is yn log x. Now it will be 1 upon yn plus 1 into yn plus 1 dash, it will be yn log x is 1 by x plus y dash n into log x. So basically derivative of f123 at 1, it will be f123 at 1 into f122 at 1 into 1 plus f dash 1221 and log 1 is 0. Now, any fn plus 1x is 1 to the power 1 to the power 1 to the power 1. So this value will always be 1. So value of f1231 is 1 and f1221 is also 1. So value of this derivative will be 1. That means this statement 28 is correct. So the correct statements are 25 and 28. Now in question number 8, we are given two sets n 1, 2, 3, 4, 5, 6, 7, 8, 9 and L, which is A, B and C. Now statement 29 is, suppose we arrange 12 elements in a line such that all three letters appear consecutively in any order. The number of such arrangements is less than factorial 10 into 5. Now we have to arrange 12 elements. Out of these 12, these three elements A, B and C, they must occur together. So we'll use string method. We'll tie them. So now we have 10 elements and we can arrange these 10 elements in factorial 10 ways. Now these three elements, we can arrange them among themselves in factorial 3 ways. So total number of such arrangements will be 6 into factorial 10, which is greater than 5 into factorial 10. That means statement 29 is incorrect. Now statement number 30 is, more than half functions from n to L have elements B in their range. So we have defined functions from n to L. So this is 1, 2, 3 up to 9, and here we have A, B and C. Now we have to find number of functions from n to L having the element B in their range. Now if we find total number of functions, then total number of functions from n to L will be, for each element we have 3 choices. So for all the 9 elements we have 3 into 3 into 3, 9 times choices. So total number of functions will be 3 to the power 9, which is 81 into 81 into 3, 19,683 functions. Now we'll find number of functions from n to L in which B is in its range. So total number of such functions will be total functions, which is 3 to the power 9 minus all those functions which do not have B in their range. So for all the elements we have only 2 choices, either A or C. So total number of such functions will be 2 to the power 9, and this is 19,683 minus 512. Now this is 19 something, which is much greater than half the value of total functions. So that means this statement 30 is correct. Now 31 is, number of one-to-one functions from L to N is less than 512. Now here we are defining functions from L to N. So we have A, B, C, and N we have 9 elements from 1 to 9. Now total number of one-to-one functions will be given by 9P3, and which is 987. The value is 504, which is less than 512. That means the statement 31 is also correct. Now statement 32 is, number of functions from n to L that do not map consecutive numbers to consecutive letters is greater than 512. So here we have 9 elements, 1, 2, 3 up to 9, and here we have the set L having 3 elements A, B and C. Now here we have 2 cases. Case 1, if all the elements they are mapped to B, so total number of such functions, it is just 1 as it is a constant function. Or this second case, when none of the element is mapped with B. Because if any element is mapped with B, then for its neighbor, we cannot choose A or C. So for each element, we have only 2 choices, A and C. So total number of such functions will be 2 to the power 9, which is 512. So number of such functions is 513, which is greater than 512. That means this statement 32 is also correct. So the correct statements are 30, 31 and 32. Now in A9, we are given a non-real complex number, that is a number of the form a plus iota b, where b is unequal to 0. And fz is z to the power 222 plus 1 upon z to the power 222. Now the statement 33 is, if mod of z is 1, then fz must be real. So if mod of z is 1, then z is basically e to the power iota theta. Then in that case, fz will be e to the power iota 222 theta plus 1 upon e to the power iota 222 theta, which is e to the power iota 222 theta plus e to the power minus iota 222 theta. Using Euler's formula, sine part will cancel, so it will be equal to 2 cos 222 theta, which is a real number. That means the statement 33 is correct. Now in statement 34, we have z plus 1 upon z equals 1. Now we can write this as z square minus z plus 1 equals 0, or z is 1 plus minus under root of 1 minus 4 minus root 3 upon 2, or this is 1 plus minus root 3 iota upon 2. So basically we have minus omega and minus omega square, where omega and omega square are complex cube root of unity or non-real complex cube root of unity. Now if we find fz will be minus omega to the power 222 plus 1 upon minus omega to the power 222. Now it's an even number and is a multiple of 3. So this value will be 1 plus 1, which is 2. And the result will be same for minus omega square also. That means this statement 34 is also correct. Now this 35 is, if z plus 1 upon z is real, then mod of fz is less than or equal to 2. So we are given that z plus 1 upon z, it is a real number. Now suppose z is r into e to the power iota theta. So we can write r e to the power iota theta plus 1 upon r e to the power iota theta. So it will be this r e to the power iota theta plus 1 upon r e to the power minus iota theta. Now we can write this as r plus 1 upon r cos theta plus iota r minus 1 upon r sin theta. Now if this is purely real, then basically this part, it must be 0. And if it is 0, then either r is 1 or sin theta is 0. But sin theta cannot be 0, as in the question it says it is not purely real. Now when r is 1, we can write fz as e to the power 222 iota theta plus 1 upon e to the power 222 iota theta. So it will be this 2 cos 222 theta, which is less than or equal to 2. That means the statement 35 is also correct. Now 36 is, if fz is a real number, then fz must be positive. Now if we write fz is z to the power 222 plus 1 upon z to the power 222. Now we'll take z as r into e to the power iota theta. So it will be r to the power 222 e to the power iota 222 theta and plus 1 upon r to the power 222 and e to the power iota 222 theta. Now we can write this as r to the power 222 plus 1 upon r to the power 222 cos 222 theta plus iota, and this is r to the power 222 theta minus 1 upon r to the power 222 into sine 222 theta. Now it says fz is a real number. Now it will be real if this is 0, and if we put it equals to 0, then either value of r is 1 or value of sine 222 theta will be 0. If we take r as 1, we'll get this as 2 cos 2 to 2 theta, and this cosine expression, it can be positive or it can be negative. And also if we take sine 2 to 2 theta as 0, then this cos 2 to 2 theta, it can be either plus 1 or minus 1. So this fz, it may be negative and it may be positive. So this statement 36 is not always correct. That means it is incorrect. Now in question number 10, it says we have n cards which are placed in a line in some sequence, and it says a move consists of interchanging the card 1 with any other card. If it is possible to rearrange the card in increasing order by doing a series of moves, then we say the given sequence can be rectified. Now this first sequence is 9, 1, 2, 3, 4, 5, 6, 7, 8, and it says it can be rectified in 8 moves and no fewer moves. Now since we can only move this first card, we'll replace this 9 with 8. So it'll be this 8, 1, 2, 3, 4, 5, 6, 7, 9. Now the second step, we'll interchange 8 and 7. So it'll be this 7, 1, 2, 3, 4, 5, 6, 8, 9. Then we'll interchange 7. Then 6 with 5, 5 with 4, 4 with 3, 3 with 2, and 2 with 1. So we have 1, 2, 3, 4, 5, 6, 7, and 8 steps. So it can be done in at least 8 moves. Now in 38, we have the second sequence, which is 1, 3, 4, 5, 6, 7, 8, 9, and 2. Now first we have to place this 9 at the end. So what we'll do is, we'll interchange 1 and 9. So it'll be 9, 3, 4, 5, 6, 7, 8, 1, 2. And then we interchange this 9 with 2. So now we have 2, 3, 4, 5, 6, 7, 8, 1, and 9. Next, we'll place this 8 here. And for this again, we have to interchange it with 2 and then interchange it with 1. So for each placement, we need at least 2 moves. So it is not possible to rectify the sequence in 8 or less moves. So this 38, it is incorrect. So 37 is correct and 38 is incorrect. Now in 39, it says we are given a sequence and it says it cannot be rectified. Now basically, once we have any sequence of number, it is possible to write an algorithm using moves to sort it out. So any sequence, it can be rectified, and therefore this 39 is incorrect. And this 40, in which we have 99 cards, it can also be rectified. So that means this 40 is also incorrect. So the only correct statement in this case is statement 37.